pen, paper, read the question, read the answer, write once or twice. Let's start. These are the common questions and answers in circuits. What is current? It is the time rate of flow of electrons. Time rate of flow of charge. Charge is better. Time rate of flow of charge. It is the time rate of flow of charge. Current has both magnitude and direction. Is it a scalar or a vector? Idu board exam go beku. It has both magnitude and direction, but it's a scalar because it doesn't follow laws of vector algebra. Okay? Current has both magnitude and direction. Still, current is a scalar. Why? Because it doesn't satisfy the laws of vector algebra. Laws of vector algebra means that p square plus q square plus 2pq cos theta resultant of two quantities. Current doesn't follow this. That is why it is a scalar. What is the direction of current with respect to direction of flow of electrons? If this is a circuit, simple circuit with a resistor and a cell. If this is the direction of current, then electrons will be traveling in the opposite direction. This is called conventional current direction. This is direction of electrons and these two are opposite. What is the SI unit of current? Ampere. What is the resistance? Resistance is the opposition to the current. Resistance of a conductor is opposition to the current. SI unit of resistance, ohm. These are simple questions. Of course, VIVA nalli simple questions irutte. Panic agbardu, ಹೆದರ್ಕೋಬಾರ್ದು. ಅರ್ಜೆಂಟ್ ಅಲ್ಲಿ ಏನೇನೋ ಉತ್ತರ ಕೊಡಕ್ಕೆ ಹೋಗಬಾರ್ದು. ಎಕ್ಸಾಮಿನರ್ ಮೈಂಡ್ ಸೆಟ್ ಯಾವ ಥರ ಇರುತ್ತೆ ಅಂತಂದರೆ ಅವ್ರು ಕ್ವಶನ್ಸ್ ಕೇಳಬೇಕು, ನಿಮ್ಮ ಹತ್ರ ಆನ್ಸರ್ಸ್ ಬರೆಸ್ಬೇಕು ಅಂತಲೇ ಕ್ವಶನ್ಸ್ ಕೇಳ್ತಾರೆ. ಓಕೆ, ಅವ್ರು ನೋಡಿ ಹೆದರ್ಕೊಳ್ಳೋದು ಮಾಡೋದು ಬೇಕಾಗಿಲ್ಲ. ಯಾವ ಟೀಚರ್ಸು ಸುಮ್ಮನೆ ಮಾರ್ಕ್ಸ್ ಕಟ್ ಮಾಡಲ್ಲ. ಯಾವ ಟೀಚರ್ಸು ತುಂಬ ಕಷ್ಟವಾಗಿರೋ ವೈವಾ ಕ್ವಶನ್ಸ್ ಕೇಳಿ ನಿಮ್ಮನ್ನು ಹೆದರಿಸ್ಬೇಕು ಅಂತ ಇರಲ್ಲ. ಅಷ್ಟು ತಲೆಗೆ ಹೋಗಲಿ. What is the reason for resistance of a conductor? Resistance is because of collision of conduction electrons with fixed ions, positive ions. Conductors, resistance is due to collision of conduction electrons with positive ions. Conductor higidre, atom in the electron aachege bandre, this becomes positively charged. So these are positive ions. Electrons ಹೀಗೆ ಹೋಗಿರೋದು ಇದಕ್ಕೆ ಡಿಕ್ಕಿ ಹೊಡೆಯುತ್ತೆ. That is true only when ends of the conductor are maintained with a potential difference. Positive ಕಡೆಗೆ electrons ಮೂವ್ ಆಗುತ್ತೆ. ಮೂವ್ ಆಗಬೇಕಾದ್ರೆ it collides with the positive ions. So this collision is the reason for resistance. What is the direction of flow of current in a circuit? The direction of flow of current is direction of flow of current is from positive to negative in the external circuit, but negative to positive inside the battery or cell. Positive towards negative in the external circuit, negative to positive inside the cell. What is DC? DC means direct current. Direction will not change with respect to time. Direct current is unidirectional current. There is no change in current direction. What is 1 ampere? Define 1 ampere. ಯಾವ ಥರ ಆನ್ಸರ್ ಹೇಳಿದ್ರು ಮಾರ್ಕ್ಸ್ ಕೊಡ್ತಾರೆ, ಬಟ್ ನೀವು ತುಂಬ ಕರೆಕ್ಟಾಗಿ ಆನ್ಸರ್ ಹೇಳಬೇಕು ಅಂತಿದ್ರೆ ಡಿಫೈನ್ಗೆ ಈ ಆನ್ಸರ್ ಕೊಡಿ. ಇದನ್ನು ಥಿಯರಿ ಪೇಪರಲ್ಲಿ ಓದಿರ್ತೀರ, ಕರೆಕ್ಟಾ? ವಾಟ್ ಈಸ್ ಅಂತಂದರೆ ಅದಕ್ಕೆ ಮೀನಿಂಗ್ ಬರೋ ಥರ ಯಾವುದಾದ್ರೂ ಆನ್ಸರ್ ಇದ್ದರೆ ದಟ್ಸ್ ಫೈನ್. ಸೊ 1 ampere current, when 1 coulomb of charge flows through a conductor in 1 second, current equal to charge by time. 1 coulomb of charge in 1 second. 1 coulomb of charge flows through a conductor in 1 second means it is said to be 1 ampere. Define ಅಂತಂದ್ರೆ ಯಾರೋ ಡಿಫೈನ್ ಮಾಡಿರ್ತಾರಲ್ವಾ ಅದನ್ನೇ ನಾವು ರೀಪ್ರೊಡ್ಯೂಸ್ ಮಾಡಬೇಕು. ದಟ್ ಸ್ಟೇಟ್ಮೆಂಟ್ ಶುಡ್ ಬಿ ರಿಪೀಟೆಡ್ ಅಂತ. ಓಕೆ, ಆ ಸ್ಟೇಟ್ಮೆಂಟ್ ಏನು ಜ್ಞಾಪಿಸ್ಕೊಳ್ಳಿ. ಫೋರ್ಸ್ ಪರ್ ಯೂನಿಟ್ ಲೆಂತ್ ಈಕ್ವಲ್ ಟು ಕಾನ್ಸ್ಟೆಂಟ್ 2I1 I2 by R. This constant is mu naught by 4 pi. Yes, ಒಂದೆರಡು ಸಲ ಬರ್ದು ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡಿ. If this is 1, this is 1, this is 1, then 2 times this, 2 constant is 10 power minus 7 Newton per meter. Newton per meter. If force per unit length between two straight parallel conductors is this, ಯಾವ condition? When currents are same, separated by 1 meter in air or vacuum. దానికి పూర్తి స్టేట్మెంట్ ನೋಡೋಣ. Force per unit length between two straight parallel conductors of infinite length separated by 1 meter in air or vacuum carrying same current experiences 2 10 to the power of minus 7 Newton per meter. Then current through each conductor is said to be 1 ampere. So this is definition. What is ಅಂತ ಕೇಳಿದ್ರು ಹೇಳ್ಬೋದು, ಬಟ್ ಇದು this is answer for what is. What is ಅಂತ ಕೇಳಿದಾಗ ಎರಡರಲ್ಲಿ ಯಾವುದಾದ್ರೂ ಹೇಳಿ. ಡಿಫೈನ್ ಅಂತ ಕೇಳಿದಾಗ ಹೀಗೆ ಹೇಳಬೇಕು. ಅಫ್ಕೋರ್ಸ್ ನೀವು ಯಾವ್ದು ಹೇಳಿದ್ರು ಕೆಲವು ಸಲ ಎಕ್ಸಾಮಿನರ್ ಒಪ್ಕೋತಾರೆ, ಯಾಕಂದರೆ ಲ್ಯಾಬ್ ಎಕ್ಸಾಮ್ ಆಗಿರುತ್ತಲ್ವಾ. ಸೊ ದೇ ಆರ್ ರಿಯಲಿ ಹ್ಯಾಪಿ. ಡಿಫೈನ್ 1 ohm. ಹೋಮ್ಸ್ ಲಾ ಉಪಯೋಗಿಸ್ಕೊಳ್ಳಿ. V equal to IR. R equal to V by I. When this is 1 volt and this is 1 ampere. If 1 ampere current is found with 1 volt potential difference, then the resistance of the conductor is said to be 1 ohm. Meaning ಬರೋ ಥರ ಸ್ಟೇಟ್ಮೆಂಟ್ ಹೇಳಿ. ಇದೇ ರೀತಿ ಸ್ಟೇಟ್ಮೆಂಟ್ ರೀಪ್ರೊಡ್ಯೂಸ್ ಮಾಡಬೇಕು ಅಂತ ಇಲ್ಲ. ಓಕೆ, it is the resistance offered by a conductor when current through it is 1 ampere under a potential difference of 1 volt. 1 volt potential difference ಇದ್ದಾಗ 1 ampere current ಇದೆ ಅಂದರೆ resistance is said to be 1 ohm. Define 1 volt. 1 volt ಅಂದ್ರೆ ಏನು? Potential difference across a conductor is said to be 1 volt when 1 joule of work. Volt ಗೆ potential ಗೆ equation ಜ್ಞಾಪಿಸ್ಕೊಳ್ಳಿ, second chapter. Work done by charge. 1 joule of work is done to transfer 1 coulomb of charge through the circuit once, then potential difference is said to be 1 volt. ಇನ್ನೊಂದ್ಸಲ 1 joule of work is done to transfer 1 coulomb of charge through the circuit once. ಒಂದ್ಸಲ ಕಳ್ಸಕ್ಕೆ. Then potential is said to be 1 volt. Potential difference across a conductor is said to be 1 volt when 1 joule of work is required to drive 1 coulomb of charge through it. Figure of merit of galvanometer. What is a galvanometer? Galvanometer is a device used to detect. It is to detect, not to measure. Okay. Ammeter is used to measure, not to detect small currents in circuits. What do you mean by figure of merit of a galvanometer? Recall the SI unit or left hand side of the equation, current by division. So current required for 1 division deflection in the galvanometer. Figure of merit is the current required to produce unit deflection in the galvanometer scale. For 1 division deflection, what is the current required? That is a measure of figure of merit. So SI unit is ampere per division. Ampere per division. Can a galvanometer measure current? Answer is no. It cannot measure, it can just detect. Galvanometer can detect. That is why there is no polarity for the galvanometer. Is there any polarity, positive or negative? No. Galvanometer has no polarity. Mention parts of a galvanometer. Galvanometer has a rectangular coil of a copper wire wound on a cylinder. So this is the cylinder. Rectangular coil of insulated copper wire on a soft iron cylinder. Soft iron is to increase the magnetic flux. Then magnet. So this rectangular coil is placed between two magnets with curved pole pieces like this. Usually magnets have flat pole pieces, but here curved. Aluminum pointer on a circular scale. Circular scale, aluminum pointer. Aluminum pointer means it is non-magnetic. What is this, or why is this method called half deflection method? Half deflection method means if current through the galvanometer is half, then deflection becomes half. That is achieved by connecting a resistor in parallel. It's called half deflection method because deflection is made half by connecting shunt resistance, a resistor in parallel. Divisions on galvanometer scale are equally spaced. Why? Because theta is proportional to I, or I is proportional to theta. If current is doubled, deflection also gets doubled. If current is halved, deflection gets halved. Means divisions should be equally spaced. 0, 1, 2. So all the divisions are equally spaced. You won't appreciate this much, but still, because other galvanometers, that is not I proportional to theta. So that's why in this case equally spaced. On the galvanometer scale, Y is 0 placed at the middle. If this is the galvanometer, if this is the direction of current, deflection can be on one side. If direction of current is reversed, then deflection will be on the other side. Galvanometer needle can deflect on both sides. That is why there is no polarity, this side or this side. Which part of the galvanometer offers resistance? Galvanometer coil offers resistance. Resistance of the coil of insulated copper wire. What is current sensitivity of a galvanometer? Current sensitivity is reciprocal of figure of merit. So it is division per ampere. Current sensitivity of a galvanometer is the number of divisions per unit current. Per unit current. This per unit current could be 1 milliampere, 1 microampere. This can be anything, unit value. Okay. Reciprocal of figure of merit. How the figure of merit and current sensitivity are related to each other? They are reciprocals. Conversion of galvanometer into voltmeter. What is a voltmeter? A voltmeter is a device used to measure potential difference between two nodes. Device used to measure, not to detect, to measure potential difference between two nodes, two junctions, 2 points in a circuit. How can galvanometer be converted into voltmeter? G to V in series. Resistor, suitable resistor should be connected in series. G to A in parallel. Right? A galvanometer is converted into a voltmeter by connecting a suitable high resistance. We cannot simply connect some resistance. It should be suitable high resistance. Its value should be calculated in accordance with the given problem. Range of the voltmeter in series with the galvanometer. How is a voltmeter be connected in a circuit? A voltmeter should be connected across ammeter in series. This is a resistor. How to measure potential difference means we have to connect a voltmeter across the device, across the element, connected parallel across the nodes in which the potential difference should be calculated, measured. If these two are the nodes, voltmeter should be across these two in parallel. What should be the resistance of the voltmeter? What is the resistance of an ideal voltmeter? Resistance, and this is ideal voltmeter. Voltmeter should have very high resistance and ideally it is infinity. Just observe the question. Are they asking for the ideal voltmeter or for just a voltmeter? Voltmeter means high resistance. Ideal means infinity. Why should a voltmeter have very large resistance? Because it should not allow some current to pass. It should not bypass the current. This is the resistor, right? If voltmeter is connected, then there should not be any current through the voltmeter or minimum current through the voltmeter. Current should be minimum means resistance of this voltmeter should be maximum, very high. Voltmeter when connected in a circuit should not draw appreciable current. Should not draw appreciable current. Is polarity important for using a voltmeter? Yes. Polarity is important for ammeter. Polarity is important for voltmeter. No polarity for galvanometer. Mention the factors on which the value of high resistance connected in series depends. High resistance depends on range and resistance of the galvanometer. Just go through the equation, range and then resistance of the galvanometer. G to A, galvanometer to ammeter. What is an ammeter? An ammeter is a device used to measure current through a branch. Current through a branch. Voltmeter across, ammeter through. How can a galvanometer be converted into an ammeter? A galvanometer is converted into an ammeter by connecting suitable low resistance in parallel. Low resistance in parallel. How is an ammeter be connected in a circuit? Ammeter is connected in series. In a circuit, in series. In a branch in which current should be measured. If this is a resistor, battery, how to measure current through this means ammeter should be connected in series. What should be the resistance of the ammeter? What is the resistance of an ideal ammeter? Ideal. Resistance of ammeter should be low and ideally it is 0. Any ammeter, low resistance. Ideal ammeter, 0 resistance. Why should an ammeter have low resistance? Because when it is connected in series, it should not offer resistance, right? Connected in a circuit, it should not oppose the current. Is polarity important for using voltmeter? Ammeter. Answer is yes. Polarity is important. Verification of Ohm's law or resistance per unit length. State Ohm's law. This is a standard question in this experiment. Ohm's law statement. Electric current is proportional to potential difference when temperature and other physical conditions are kept constant. Electric current flowing through a conductor is directly proportional to potential difference across its ends, provided physical conditions, temperature and dimensions of the conductor remains same. Constant temperature. There should not be variation in dimensions, length, width. There should not be any change. In that case, V is proportional to I. Mathematical form, V equal to IR. Limitations of Ohm's law, also required for board exam. Cannot be applied to vacuum tubes. Cannot be applied to semiconductors at all voltages. It's important to mention at all voltages. because in semiconductor device we will be using Ohm's law, but in a range or after some value or before some value where linearity is observed. So that's why it's better to use semiconductors at all voltages. Ohm's law cannot be applied if temperature of the conductor is not constant. If temperature changes, then resistance changes. In that case, V is not proportional to I. What is current? Time rate of flow of charge. What is resistance? Resistance is the opposition offered by the conductor to the flow of current. Resistance offered by the conductor to the flow of current. What is the SI unit of resistance? And resistance per unit length. Unit of resistance is ohm. Resistance per unit length, ohm per meter. Mention the factors on which resistance of a conductor depends. Length, resistance, rho L by A. See, resistance depends on length, area and material, copper, silver, gold, type of metal. Length of the conductor, area of cross section, resistivity of the metal, material and temperature of the conductor. Of course, temperature dependence, there is another equation, but let us include that here. How are ammeter and voltmeter are connected in a circuit? In a branch, ammeter in series, voltmeter connected across a resistor. Since it is Ohm's law, verification of Ohm's law or resistance per unit length, voltmeter should be across, means parallel to the resistor. Ammeter in series. What happens to resistance of a conductor when its length is doubled? R equal to rho L by A. Since we are using a wire conductor in the experiment, they may ask such question. What happens to resistance if length is doubled? Length is doubled means resistance gets doubled. If area is doubled means resistance becomes half. What happens to resistance per unit length of a conductor when its length is doubled? Resistance per unit length. When length is doubled means it remains same. Why? Resistance per unit length. Every time it is measured per meter. There is a wire. This is 10 centimeter wire. Resistance per unit length means some resistance by 1 meter for 1 meter length. If there is a conductor of 2 meter, still it is measured for 1 meter. In that sense, resistance per unit length is independent of the length. Resistance depends on the length. Resistance per unit length is independent of length. What is a rheostat? What is the function of the rheostat? Rheostat is a variable resistor. It has a wire where its length can be measured, varied. According to that, resistance changes, which is used to control current in a circuit, which is used to vary the potential difference. Rheostat is a variable resistor which is used to vary current through a circuit. Current changes means potential difference also changes. Name the physical quantity obtained by taking slope of current versus potential difference. Graph of current by potential difference. There is a slope delta I by delta V. So delta I by delta V is reciprocal of resistance. If it is current by voltage, reciprocal of resistance. If it is voltage by current, it's resistance. Observe the question carefully. Corresponding to that, you give the answer. Name the physical quantity obtained by taking slope of voltage versus current. Voltage versus current. It's the resistance. Current versus voltage. Voltage versus current. How does the resistance of a conductor vary with the applied potential difference across it? Resistance is independent of the potential difference. Potential difference is the externally applied. Resistance is for the material dimensions. So it is independent. Independent. You should not say V equal to IR. Therefore, resistance is directly proportional to potential difference. No. Current is directly proportional to potential difference. Resistance is constant. How the resistance of a conductor does vary with the current through it? Resistance is independent of the current. Define resistivity, specific resistance. So, favorite question. Resistivity is the resistance per unit length, per unit area of cross section. Resistance equal to rho L by A. Resistivity is resistance per unit length, per unit area. Important question. What is the SI unit of resistivity? Ohm meter. Ohm meter. Mention factors on which resistivity of a conductor depends. Its temperature and impurity of the conductor, impurity of the material. Again, R equal to rho L by A. What happens to resistivity if length is doubled? No. Resistivity depends on temperature, independent of other factors. What happens to resistivity if area of cross section is doubled? No change, because resistivity depends on temperature and the material, of course. Impurity. If length of a conductor is doubled, what happens to resistivity? No change, because resistivity is independent of physical dimensions. Resistance depends on physical dimensions, means length, thickness. How resistivity of a conductor depends on length? No change. Here, doubled. How it depends means no change, is independent. How resistivity of a conductor depends on area of cross section? Independent. What is a meter bridge? Meter bridge is modified form of Wheaton's network. Modified form of Wheaton's network. What's the principle of meter bridge? Balanced Wheaton's network. Important question. What happens to balancing point when resistance in the right gap of the meter bridge is increased? Now, meter bridge and then Wheaton's network. Let me draw both. This is the Wheaton's bridge, right? P, Q, R, S. And this is the meter bridge. There is this resistor, one more resistor, and then galvanometer, and then jockey. This is how it is, right? P, Q, this is R, this length, resistance of this length is R, this is S, this by this equal to this by this, P by Q equal to R by S, P by Q equal to R by S. See, if this increases, this should increase. Means if this increases, this should increase. Now observe, what happens to balancing point when resistance in the right gap? Resistance in the right gap. Where is that right gap? Here is the right gap. This is the right gap. If this increases, means this increases, what happens to R? R is here. If this increases, then Q increases, then R should decrease. If denominator increases means this ratio decreases. Therefore, R should decrease. It should decrease. Don't panic. When such questions are asked, take some time. You can request for pen and paper, draw, and according to that you try to answer. Though it's an oral examination, you can just request for a few seconds, draw, then analyze, then try to give the answer. In a meter bridge, what happens to balancing point when the resistance in the left gap is increased? Resistance in the left gap is increased. This is the Wheaton's bridge, right? Wheaton's bridge. If resistance of the left gap is increased, then this is the balancing point, should increase, because this by this equal to this by this increases. If this increases, this should increase. If this increases, then this should decrease. In a meter bridge, why thick metal plates are used? Thick metal plates means resistance offered by metal plates is minimum, very small compared to resistance of the wire, and does not contribute any resistance to the meter bridge. We are doing experiment. Those metal strips should not contribute resistance. That's why they are made thick. What is balancing point? Null point. Balancing point on the meter bridge is the point of contact of the jockey where galvanometer shows null deflection, zero deflection. It is that point on the wire of the jockey where deflection becomes zero, where current through the galvanometer becomes zero. Anything is fine. What is balancing length? Balancing length is length of the meter bridge wire for which galvanometer shows null deflection. It is that length of the meter bridge wire where galvanometer shows zero deflection. What is the current through the galvanometer and potential difference across the galvanometer at null point? Current is zero, potential difference is also equal to zero. What is the balancing length if resistance of the galvanometer is doubled? What is the balancing length if resistance of the galvanometer is doubled? Balancing length is when current through the galvanometer is zero. There is no current through the galvanometer, therefore no change, doesn't affect. What is the balancing length when length of the meter bridge wire is doubled? Length of the meter bridge wire is doubled, gets doubled. Balancing length gets doubled. Means if we are using 1 meter wire and balancing length is 10 centimeter. Okay. When we use a meter bridge of wire 5 meter, total wire is 5 meter, then balancing length should be 5 times this, 50 centimeter. Because what matters is potential difference per unit length matters. Potential gradient. What is the balancing length when galvanometer and battery are interchanged? Required for board exam. No change. Among meter bridge and verification of Ohm's law experiment, which method gives accurate method of measuring resistance? It's the meter bridge, because comparison. There it depends on voltmeter resistance, ammeter resistance and other factors. But here it is independent. So meter bridge gives accurate measurement.